Right. So in this lesson, we'll talk about related rates and why are they called related rates? It's because if we look at, for example, a square, and we know that the sides of the square are increasing at a rate of dx dt, we can talk about the rate of increase of the rate of change of the area. If dx dt is 2, dA dt won't also be 2. It'll be a different rate, but it's related. And we can look at a relation. The area of the square is x squared. So area and side length are related by this. And then we can say that their rates are related like this. And we have to use dA dt, so this is the rate of change of A with respect to t, the rate of change of x with respect to t. So in everything before this, we have x as a variable, now x is a function of time. So here's one type of question for related rates. The relation is given. A lot of times the relation is a geometric relation that you have to remember. But here it's given. The relation is given, and we can just organize it like this. So this will be a constant, this will be a rate, this will be given and find. So a given constant, well, there's a rate, there's a constant, x equals 3. Here's a given rate, dx dt. And we're going to find a rate, dy dt. Find the rate. And then we can relate x and y. The relation is given. So that's how x and y are related. Now we need to find out how dx dt and dy dt are related. How are the rates related? So we have dy dt. Let's do the derivative of this. 2x dx dt minus 3 dx dt and we want to solve for dy dt, and we just substitute for x 3, dx dt is 2, and we have 4, 12 minus 6. 6 times 2 is 12. This one you can do the same way, but there's something missing in the question that you have to find. You have to find a constant, and I'll just tell you that you're given x, you'll need to find y. So go ahead and pause the video and try this one. Constant rate given, find. The given constant is 3. The given rate is dx dt. Find dy dt. And how are x and y related? X and y are related with this relation. We want to know how the rates are related, so we have the derivative of this is 2x dx dt, 2y dy dt equals 0. And just like, well, this is implicit differentiation, but instead of, in the previous lesson, x was a variable, and I would only have to include dy dx when I did a derivative of y. Now x and y are both functions of time, so the x is some function of time. We do the chain rule where there's some inside function here, derivative of the outside, leaving the inside the same, times the derivative of whatever x is in terms of t. And that's why we have to do this dx dt. We're going to substitute. We know x, dx dt. We're going to solve for dy dt, but we don't know y. And that's what we have to find. We have to find y. To do that, we can just use the given relation. And we know x. (9 minus 9). So we get y equals 4. And we should say positive or negative. So in this case, we'll go ahead and use both of them. And so we have 2, and x is 3. Dx dt is 8. And then we have y is a 4, and solve for dy dt. 24, 48. And we'll subtract 48 and divide by 8, so that's negative 48 over 8, negative 6. We have the positive 4. Well, if we had the negative 4 over here, put a negative in there, that would be a negative, and that would give us a positive 6. So this is how a lot of the related rates problems are asked. They're asked about some geometric shape. So we have a sphere, and the radius is decreasing. Let's organize it. Constant rate given, find. And here we have the r, and it's dr dt. We have v and dv dt. find the rate of change of volume, we're going to find dV dt. The radius is decreasing, so we say dr dt is -2 centimeters per minute. A given constant is the volume is 30 cubic centimeters. And then we just have to relate the radius and the volume. Volume of a sphere is 4/3 pi r cubed. Let's relate the rates. dV dt, find the derivative of this, multiply by 3, it'll cancel that 3. dr dt, and substitute for r and dr dt. We don't know r, but we can go back and find it. And so when you see one of these problems that you eventually have to find something, you're just going to figure that out down here. Maybe you don't know it in the beginning, but as you go through it, you say, oh, I'm missing r, but we do know v, and we have v is 4/3 pi r cubed. We need to find r, but we know v. And we'll multiply by 3 is 90, divide by 4, and divide by pi. And then cube root. So we have 4 pi, and that will be the cube root of 90 over 4 pi times -2, and that is approximately -93.382 cubic centimeters per minute. All right. Pause the video and try this one. So for a sphere, the picture is not that important. We just know there's a radius and a volume, and here the radius, the volume is increasing, so we know the radius is increasing. For other types of shapes, it'll be more important to draw the picture. Constant rate given, find. So we just read through it. Volume increasing, so that's a given rate. dV dt 60 centimeters cubed per minute. Find the rate, so find a rate, the rate of change of its radius, dr dt, when the radius is 10 centimeters. So the relation for the sphere volume is 4/3 pi r cubed. dV dt is 4 pi. That looks like a 0.4. So multiplied by 3, we get 4 pi r squared dr dt. We know dV dt, 4 pi r. We have r. We just have to solve for dr dt. R is 10. And we have 60 divided by 100 times 4, 400 pi. That's dr dt. And we have 0.048 centimeters per minute is dr dt. So those were with spheres. Now let's look at right triangles. So let's draw a picture. We have the wall, and the ladder's leaning up against the wall. We know that the top of the ladder is falling down, and the base of the ladder is going away from the wall. So we have x and y, and then we have dx dt and dy dt. We know that the length of the ladder is 30. And we know dx dt is 1/2 foot per second. And we're going to find dy dt when it's 3 feet above the ground. So let's put all that, let's organize all of that. We have a constant, a rate, given, find. So rates, we have dx dt 1/2 foot per second. We're going to find dy dt when y equals 3, and x and y are related. The lengths x and y are related by x squared plus y squared equals 30 squared so we'll find dx dt, 2x dx dt, 2y dy dt equals 0. Solve for dy dt. We know y, but we need to find x. So we have to find x when y equals 3. So that's going to be x squared plus y squared equals 30 squared. And y is 3. All right, so now we have over here 2 times x, 29.845 8.4962. I didn't round it because I'm going to use it, and then I'll round it at the end. Dx dt is a half. Y is 3. And solve for dy dt. So we're going to subtract and divide. Dy dt is, let's say, 1/2 of that is 1. So we just have negative 29.84962 divided by 6. And that is about negative 4.975 feet per second. Okay, we were going to do another example with right triangles, but I think we need to move on to a different type of problem using triangles. And we have this problem. So there's a pile of sand that makes a cone. And we have sand being poured onto it. So as more sand is poured, it gets wider and higher. We know that dV dt is 30 cubic feet per minute. And we know that the base, this length, and the height are equal. Find dH dt. So we know that should be h. But let's call this length x. And we know that x is, if this length is equal to this, then this length must be h over 2. So let's look at organizing it. The given constant, when the height is 10 feet, the given rate, dV dt is 30. And find a rate. Find dH dt. How fast is the height increasing? So now we have a relation for volume and height of a cone. And with the volume of a cone is 1/3 pi r squared h. Now, we didn't call this the rate. We should call it the radius, but here it doesn't matter because we're just going to replace it with h squared. We don't want to have, it would be nice not to have 3 variables, so why don't we just change that? We know that the radius is half of the height. So before we find the derivative, this is going to be h squared times h is h cubed over 4, because that's 2 squared. And now we have 1 over 12 pi h cubed. So dV dt, we'll find the derivative by using the power rule multiplied by 3, so that's 3 over 12. And dV dt is 30. This would be 1/4 pi. H is 10. Solve for dH dt. So we have 30 over 100, and then we also have to divide by this. 30 over 100, and then we're going to multiply by the reciprocal of that, times 4 over pi. That is dH dt. And we can reduce okay. $25. Six over 5 pi is the right answer, and I don't know why I'm not getting that. 30 over 100, 4 over pi, 120. Well, I have 120 over 100. That's going to work out to be 6 over 5 pi. Oh, here it is. Cross. I can't do that. It's going to be 2, and this is going to be a 5. So 6 over 5. There we go. 6 over 5 pi. All right. So instead of writing all of the dimensions and the shape of the container, let's just draw the picture, and we're going to find rate of change of height of the water when height is 30 centimeters. So right away, look at how this is in meters and this is in centimeters, so we have to be careful. And here are the dimensions of the container. We have, and they'll call that an isosceles trapezoid. And then it goes back like this. Okay. This is going to be an important step in the problem. We'll say that this is 10 meters, and we know that the height of the container is 50 centimeters. The base is 30 centimeters, and the width is 80 centimeters. It's going to be filled with water, and the depth or height of the water is 30 centimeters. Okay, so, but we still have to deal with a proportion, and we're going to deal with similar triangles, and that's going to be done since we don't have the a triangle here. We just take this part of the triangle. If there is some relation with the trapezoid, I think people are going to forget that, and we'll just look at the triangle right here. Now, we know that's 30, and the whole length is 80. So that means there's 25 here and 25 there. 25 plus 30 plus 25 is 80. Now we have the dimensions of the right triangle. And we need to look at the ratio of the sides of the right triangle so we can reduce the number of variables. If we have a 25 here and a 50 there, then when the water fills up, we want to know about, we know that's 30, and what's that going to be? It's going to be less than 25. So we're going to have this small triangle, this similar triangle to that one, and that's going to be 30. And we can see that whatever the height is here, whatever the height is, the base is going to be half of that. So it turns out to be similar to the previous problem because we have that same ratio, but the difference in this one is going to be when we look at the full trapezoid, we have the height, and then this is going to be, this won't change, it's still going to be 30, but this is going to be 30 plus h over 2 plus h over 2, because we have h over 2 here, we have h over 2 there. This h over 2 is going to be on the right and on the left. We have two of them, so that's going to be 30 plus h. All right, let's do the organizer, constant rate. Given, find. The given constant is the height. And since we're dealing with meters and centimeters, let's go ahead and do everything in meters. So instead of writing the height being 30, I'll write the height of 0.3 meters. And then the rate. Find the rate of change of the height. And we have the rate of change of the volume. Volume is 0.2 meters cubed per minute. And now we have to relate volume and height. So volume is, it's going to be the area of this trapezoid times the depth of the trapezoid. So the area of the trapezoid is going to be the height times the mean of the two bases. So it's 30 plus h, that's 0.3 plus h plus 0.3 divided by 2. All right, and then that's multiplied by 10. So we have the area of the trapezoid times the length of the container. Okay, we can do some simplifying here, and we have a 1/2, so that'll change that to a 5. And in here we have 0.3 plus 0.3 is 0.6. 0.6 plus h times 5. And if we multiply by 5, we have 3 plus 5h, or 3h plus 5h squared. And the derivative dv dt is 3 dh dt plus 10h dh dt. We know that dv dt is 0.2. dv dt is 0.2. So we have 0.2. We're going to solve for dh dt. So you have 3 plus, and this will be 10 times h. That's 0.3. So we have the dH dt. I'll put it outside, factor it out, and then 3 plus 10 times h. So this is going to be 3 plus 3 is 6. And then we have 2 over 10 equals 6 dH dt. Divide by 6, and we'll have 2 over 10 times 6, and that is in meters per minute. Reduce that to 1 over 30 meters per minute. We could put it in centimeters by multiplying by meters per minute is divide by meters multiplied by 100. So we have 100 over 30 is 10 over 3 centimeters per minute. All right, and we'll stop there.